Hi friends, welcome to Curie Electronics. Today we are going to learn about resistors connected in parallel. What do you mean by resistors connected in parallel? So, resistors connected in parallel. Resistors connected in parallel. Connected in parallel. Resistors connected in parallel. When the resistors are connected in parallel, how it looks like? It looks like, here I'll draw it. We have three or more resistors. Now we will consider three resistors. Second resistor, then the third resistor. If three resistors are connected in parallel, then we will apply voltage here. The voltage across all the resistors are same. This is the V voltage applied. If the voltage across all the resistors are same, these resistor values are R1, R2 and R3. If voltage across all these resistors are same, then these resistors are said to be connected in parallel. In a parallel circuit, what happens? Voltage remains same. Here the voltage drop will be V. Here also this will be volt V. Here also it will be V. So voltage is constant. Voltage is same for all resistors which are connected in parallel. Now, what is the current flowing through this? If current I is flowing here, then this will consider as I1 flows here. Here, what are the I2 current flows, and here I3 current flows. Now we can write now the currents are different. All these currents are different. So what is the total current I? I we can write it as I equals I1 plus I2 plus I3. Sum of these three currents will give the total current I. Now what is I? This is IT. Okay, we can take it as I total. IT. IT is this. So IT, what is current as per Ohm's law? Voltage by resistance, that is V by RT. Okay, now what is I1? V by R1. V is constant for all the resistors, not constant, same for all resistors. Now I2, what is I2? V by R2 plus V by R3. We can write it like this. So that means what is the current through, what is current I3? Voltage across I3, the voltage across R3 divided by R3. So what is current I2? I2 equal to voltage across R2 divided by R2 divided by the resistor. So similarly, so now we wrote, now what we'll do? We will simplify this equation. V by RT equals, we will take it as common. What will be left? 1 by R1 plus 1 by R2 plus 1 by R3. We will be left with this. Now we can cancel it. So we will get equivalent resistance. 1 by RT equals 1 by R1 plus 1 by R2 plus 1 by R3. So this is the equation. This is how we will find equivalent resistance of resistors connected in parallel. So this is the equation. That's one more simple. If only now you consider two resistors are connected in parallel. What is the total resistance? RT. RT. This RT is a R1. This is R2. R2. This when two resistors are connected in parallel. If you apply here and simplify this, it comes to R1 multiplied by R2 divided by R1 plus R2. R2. This is when two resistors are connected in parallel. Now we have a number of parallel resistors with same value. Then what you will do? What is the equation? See you take this two or three resistors connected in parallel. All are connected in parallel. What is RT? If we measure this here, what we will get RT? What is our RT? If number of resistors of same value are connected in parallel, all of these are R. And R. What is the equivalent resistance value? RT equals R divided by number of resistors N. Okay, so this is also an important formula. As we say, find, we'll see here once. We'll see here one simple question we'll see. See, assume that we have 1, 2, 3, and 4. 4 resistors are connected in parallel. All are 1000 ohms. Okay, 1000 ohm. 1000 ohm. This also 1000 ohm. What is these 2 points? Let us assume it A and B. What is the resistance across A and B? That is RT across AB equal to R divided by N. N is the number of resistors. What is the value of R? 1000 ohm. 1000 divided by N equal to 4. What is the value? 250 ohms. We'll get 250 ohms. So guys, I hope you understood how to find the equivalent resistance of a parallel combination of resistors. So thanks for watching. Next lectures we will see parallel and series combination of resistors.